Hi students, this is the first part of the graph plotting using the Excel function on your laptop. So the first part is we're going to learn how to plot a graph. So to do so, we are looking at plotting a graph of absorbance on the y-axis against concentration on the x-axis. So first of all, you can copy and paste your table of data into the Excel sheet. So to insert a graph, what you need to do is to click on the Insert button on the top toolbar and go to this particular button where you can plot a scatter graph. Okay, so click on the scatter graph plot, the scatter plot, and then we can actually select data. So we right click on the diagram and we can select our data from here. Okay, so with that, we can add a graph where we can type in a series name. Okay, so basically we can type absorbance versus concentration. Okay, and here is the series x value. So what we can do is to select the x value data and click on this. So to select the y data value, we do the same thing. And we click on this for your solutions A to E. And click OK. Okay, the plots will be up and the title will be in. So to edit on the data, what you need to do, or rather on the axis, you just need to click on the text box and key in the units required, and that will be fine. Okay, so to add in a trend line, what we would do is to click on the data point and right click on it. What we can do is we will add trend line, which is here. Okay, so our calibration curve should be a straight line, so we'll choose a linear graph. And you can choose whether you want to set your intercept at 0, 0, which I will do. Get the equation of the graph as well as the R-square value to see if your straight line, your linear graph is actually in good agreement. Okay, so with that, I can arrange this. So I'll get a nice straight line calibration curve from here. Okay, so with that, you will realize that the title of my x-axis and my y-axis, they are not labeled. So in order to do that, what we can do is to click on the graph. Okay, under Chart Design, the Chart Design tab, there is an Add Chart element. So you can click on it, and you will see here, there will be Chart Title and Data Label, Axis Titles. So to label the X and Y axis, we can actually click on Primary Horizontal, that will be your axis, to label your x-axis. Okay, so over here, this is concentration of copper 2 sulfate solution, so you can type it in, and do be reminded that you're supposed to write the units in. Okay, so you wouldn't be able to find a superscript. You can actually right click, go to font, and do a superscript. If you know your shortcut, please go ahead and do it. So let's repeat the same, and we're going to do on the y-axis under our axis titles, under vertical axis. So over here, we can change this to absorbance, and we get our calibration curve plotted from here.
In the previous video, we've learned how to make use of the calibration curve and the equation of the line to determine the concentration of the unknown solution by simply putting in the absorbance value as y and making use of the equation to solve for x, which correspond to the concentration of the unknown solution. So in this part, we're going to learn how to determine the absolute uncertainty for the concentration of the unknown copper 2 sulfate solution. Going back to your practical handout on page 5, there's actually this particular part of instructions to inform you that the uncertainty for concentration of unknown solution is to be determined by using the maximum and minimum slope method, and this is especially important if your IA or EE involve this particular method of using the UV-vis. So what we need to do is we need to plot the maximum slope and the minimum slope from 2 points on our calibration curve, and usually we'll use the 2 extreme points and making use of the absolute uncertainties for the concentration and the UV-vis. And from there, we will further use this formula. Uncertainty of concentration will be given by half the difference between the max and min concentration. To illustrate this better, we're going to use the Excel file to show you how to do this. Before we start plotting the calibration, the maximum and minimum curve for the calibration curve, we will need to go back to the procedure on how we prepare solutions B to E via serial dilution. From these steps, we need to then determine the absolute uncertainty for the concentration of the solutions for B to E. You will realize that for solution A, there is no absolute uncertainty because it's a stock solution that you actually obtain from the lab. Now that we have obtained the absolute uncertainty for the concentrations for samples B to E from error propagation, we can first transfer it over to this Excel file. And then the absolute uncertainty for our absorbance value is actually over here. It corresponds to that of the UV-vis machine that you use in the lab. You'll be able to obtain the absolute uncertainty from the information of the UV-vis machine you use. But to take note that the absolute uncertainty for the absorbance value may change based on the machine you use, as well as there is a limitation of if it exceeds a certain absorbance value, the absolute uncertainty may change. Do take note of that. To plot the minimum and maximum slope, or rather to use this method to determine the absolute uncertainty for an unknown solution, we will need this absolute uncertainty, meaning the absolute uncertainty for the concentration of my standard solution as well as the absorbance value. So first, we are going to plot the minimum slope. In order to plot the minimum and maximum slope, we will choose the 2 extreme points on our calibration curve. In this case, you realize that sample A do not have an absolute uncertainty, so the best option we will choose is that of sample B and sample E as my 2 extreme points to plot my maximum and minimum slope. So if I were to label it on the image that I've chosen for better reference or clearer reference, this point on the calibration curve, let it be that for solution E, and for this point, let it be that for solution B. So if I were to look at solution E itself, you will see that the concentration of solution B, which is on the x-axis, will be that of 0.005, and the absorbance value will be on the y-axis, which is 0.052. And for solution B, the coordinates will be given to be 0.04, its concentration, and 0.459, the corresponding absorbance value at this concentration. So to plot the minimum slope, I will need 2 points. First, this corner and this corner to get my minimum slope. So how do I actually get the coordinates of these 2 points? If you look at that for point E, to get the left top corner point, I'm actually looking at that from point E based on the difference of the X uncertainty, which is that for the concentration of solution E, and the Y uncertainty, which correspond to that of my absorbance value of E. So, to get the coordinates of this point to plot the minimum curve, it will then be the concentration 0.005, okay, 0.005, which is its concentration, subtracting away the X uncertainty, which is minus 0.000 2 over here, and the y coordinate will be 0.053, the absorbance value of E. Adding to the y uncertainty means you add to the absolute uncertainty of the absorbance, which is 0.005. So doing the same thing for coordinate B, I'm looking at this point to plot the minimum slope. So in order to get the coordinates of this point, you will see that it's point B, adding the x uncertainty and subtracting the y uncertainty. So to get the coordinate for this bottom right corner point, it will simply be just (0.04) added to the x uncertainty, which is 0.0003, and the y uncertainty, which is the absorbance value of 0.459, subtracting the y uncertainty of 0.005. So with that, I will get the coordinates for the minimum slope. So what I will do is, I'm just going to plot it for you to see. So for the minimum slope for the x and y coordinate, which is the concentration and the absorbance, okay, it will be of point E first. Okay, let's look at point E. So the x coordinate for this minimum slope will be equals to the concentration of B subtracting the x uncertainty. And that for the y coordinate is actually equals to the y, which is the absorbance value, added to the y uncertainty of 0.005. So doing the same for B, it would be equals to the concentration added to the absolute uncertainty on the x-axis, and for the absorbance value, it will be equals to the absorbance, okay, minus away the y uncertainty of 0.005. So with that, I'll get the 2 points of the minimum slope. So with that given, we can just plot it on the same graph, my minimum slope, by selecting data, add. Okay, let's see, we call it the minimum slope, and the x value will be this, and the y value will be this. Okay, so with that, the minimum slope will be plotted, and we can actually get the equation. Okay, we can go to chart design, add element, and 9. It's got to be linear for the minimum slope. Okay, so with that plotted, let's see, you can actually get the r squared and the equation for use later on. Okay, so this is how we get our minimum slope. Okay, next we are going to plot the maximum slope for this calibration curve. So in order to plot the calibration curve, we're going to use the same idea we did just now. So the calibration curve is plotted using this point, and this slope that we plot will be known as the maximum slope. So in order to get the x and y coordinate for the maximum slope for sample E, what we're going to do is, using the same idea as just now, go and take the coordinates of E, which is 0.005, and by looking at it, we are supposed to add the x uncertainty, which is 0.0002, which is the absolute uncertainty for the concentration of sample E. And for the y coordinate, we'll take the absorbance value of E, which is 0.053, and we're supposed to subtract the y uncertainty, which means we subtract away 0.005, the absolute uncertainty of the absorbance value. Using the same idea, we look at sample B. For sample B, we are looking at this point where we'll be taking the x-coordinate of B, which is 0.04, the concentration, and we are supposed to subtract the x uncertainty, which is subtracting away 0.0003, the absolute uncertainty for the concentration of sample B. And for the y-coordinate of this point, you will be taking the absorbance value, that will be 0.459, okay, adding to the y uncertainty, so we plus 0.005. So with that, we'll get the coordinates of the 2 points to plot the maximum slope. So I'll shift the graph away to make space. Okay. And then now we're going to just put in our points. So if we look at solution E first, the x-coordinate will be given by the concentration of solution E, adding the absolute uncertainty for the concentration, and the point for absorbance will be that of the absorbance value corresponding to sample E, subtracting away the absolute uncertainty of 0.005. So for sample B, we do the same thing. The x-coordinate will be the concentration of B minus away the absolute uncertainty for the concentration. The absorbance point, or the y point for the absorbance value, will be given by taking the absorbance value of B, adding to the absolute uncertainty of the absorbance value of 0.005. So with that, we'll get 2 nice points for us to plot our maximum slope. So the idea is the same. We're going to go and select data once again and add the max slope with our x value and y value inserted in. Okay. Alright, so with that, we'll have the maximum slope plotted. Okay, to add the trend line, we can go back to chart design, add chart element, trend line, and linear. So we'll select max slope, and then we will add in the equation and the r-squared value for it. Okay, so with that, we get our max and minimum slope plotted. How do we actually determine the uncertainty for the concentration of the unknown solution after having obtaining the equation for my maximum slope and my minimum slope? So if you go back to your handout again, it says that uncertainty of concentration is equals to half the difference between the maximum and minimum concentration determined. So returning back to the calibration curve and the max min slope we've plotted with the respective equation, we're just using this for illustration. So for now, you have already determined the concentration of my unknown solution previously in the second video. So now we're going to obtain the concentration using the maximum slope. Okay, so how do I do it? It's still the same. Concentration of solution using maximum slope. So same thing, based on the equation of the curve of the maximum slope, y is equals to 12.058x minus 0.0147. So now same thing, we're going to determine x, right? So y will be the same absorbance as 0.339 because we want to determine what's the maximum and minimum concentration based on the possible uncertainty that is present at the same absorbance value. So if we are to calculate the concentration determined by using the maximum slope, we just need to sub in, same thing, y equals to 0.339. So to solve for x, it then will be 0.339, okay, added to C, which is 0.0147, and then divide it by 12.058 by using the equation of the maximum slope. So from here, you will determine the concentration from the maximum slope to be 0.02933 mole per dm cube for the unknown solution. So now we're going to determine the concentration using the minimum slope. So same thing, making use of the equation, we still sub in the absorbance to be 0.339. Based on the equation, I will need to subtract away this value of 0.0045 to solve for x, which is the concentration, right? So I need to divide by 11.155. So then I'll get the concentration from the minimum slope. So with that, I'm going to determine the uncertainty. So now, with the concentrations of the unknown solution that's determined by the maximum slope and the minimum slope obtained, we're going to make use of these concentrations to find the absolute uncertainty for the concentration of the unknown solution. So if we were to go back to your handout, the uncertainty of concentration, to be more specific, the absolute uncertainty can be found by half the difference between the concentrations that's determined by the maximum and the minimum slope. So going back to my Excel spreadsheet, I'm going to calculate the absolute uncertainty by taking the difference between the concentration that I found for my maximum and minimum slope and halve it. So this will be the absolute uncertainty for the concentration of the unknown solution. If you were to recall Unit 11, absolute uncertainty should be placed to one significant figure and rounded up. So I would actually present the absolute uncertainty for this unknown solution, the concentration for this unknown solution, to be at 0.0004 instead of 0.0003. So with that, I will put it into the table. Same thing, back to the same unit. The number of decimal places my concentration should be represented to will be that of the absolute uncertainty. So since my absolute uncertainty is to 4 decimal places, my concentration will be placed to 4 decimal place, and this will be fine. So with that, I hope that these 3 videos will be useful for you when you're trying to determine the absolute uncertainty for an unknown concentration of solution when you are using your UV-Vis as your analytical method and through this maximum minimum slope method.